Hello, everyone. This is Mr. Minnick. That's my name. Math is my game. Today I'm joined with my Algebra 2 class, and we're looking at factoring quadratic expressions. All kind of people say all kind of things about factoring. They say it's an F word. Well, yeah, it is. It starts with the letter F. They say it's horrible. Well, it's not that bad. Factoring and foiling are the same thing. By the end of this lesson, you should be able to factor GCFs. You should be able to factor special quadratic expressions. And I told this class that we're going to get right to it. So here we go. I'm going to say a couple things about factoring before we get started. Factoring is division. It's dividing. When you factor, essentially what you do is divide. If you don't believe me, what I'd like to do is show you a quick example of what I mean. Example, find prime factors. Find prime factors of 72. Now, I don't know if you remember doing a prime factor tree or not, but when you do that, you start with the very first prime number. And the very first prime number isn't 1, it's that other one. What's the first prime number? It's 2. So we see, is 72 divisible by 2? And yeah, 72 is divisible by 2. So we break 72 off into its prime factors of 2 and whatever 2 times, I guess it's 36. So when I had my pre-algebra students make factor trees, I'd tell them to box in any of the prime numbers. You don't have to do that, but that's just the way I kind of showed them to do it. So then we look at the 36, and again we branch off, and 36 is divisible by 2 18 times. And 18 is divisible by 2 9 times. And then when we get down to 9, we realize, 9's not divisible by 2. So we go to the next prime number, which would be 3, and we say, oh, so 9's divisible by 3 times, and 3's prime, and 3's prime. And yes, I did repeat myself, and yes, I did repeat myself. So the prime factors of 72 are 2 times, let's see, 2 times 2 times 2, that's 2 cubed. And then 3 times 3, so that's 2 cubed times 3 squared. Now, one thing that many people try to do, and sometimes they fail, some people rely on technology, and I love technology. I'm not saying don't use it, but technology sometimes will do what you want it to, and sometimes it won't. Just like a car, if you'd imagine a car, think of in the news a few years ago, about a year ago, remember Toyotas? Everybody said, oh, don't buy a Toyota because the gas pedals stick. Do you know what happened with those? It wasn't the gas pedal sticking. It was some idiot accidentally hitting the gas pedal instead of the brake pedal. But that's another story. So technology will do what you tell it to, but sometimes it doesn't know how to do what you want it to do. And I'm going to show you today the difference between the TI Inspire and the Inspire CAS, and why you're not allowed to use an Inspire CAS on the OGT, on the SAT, on the ACT, on a park test, or anything like that. So in about 7 minutes, both of these calculators are going to try to load at the same time, and they're going to conflict with each other. So here comes my regular TI Inspire, I think. And there's the conflict I was expecting. I know. Okay, that's fine. I'm good with that. So on my TI Inspire from a calculator page, what I'd like to do is I'd like it to see if it can factor for me. And believe it or not, it can. So I'm just going to ask the TI Inspire, and I'm going to try this in the CAS and see what happens in the CAS. But I'm going to the Inspire first. So here's my regular, where is it? Where's my regular Inspire? That's my CAS. Where'd the Inspire go? It looks like the CAS overrode the Inspire. So here I am. I'm going to try to factor. I'm going to try to factor the number 72. I said I'm going to try to factor the number 72. And for some reason, when I get to the 7, all of a sudden, this thing wants to fight me. So I'm going to factor 72. And it gives me the prime factors. Okay? So if I ask the calculator to factor a number for me, it gives me the prime factors. Is everybody okay with that? Now the regular Inspire will actually do the same thing. Okay? And for whatever reason, the regular Inspire said, no, we're not going to open. So I'm going to try to open that, and we'll go back to this factoring business while that's trying to load. I have a feeling my computer really hates me. Yeah, my computer hates me. My computer hates me. Let's look at another example of 72. Find the factors of 72. Okay? Find the factors. A minute ago we found the prime factors, but if we're asked to find the factors, this is a little bit different. This is where we find all the factors. And factors, if you don't know, they're integer pairs whose product is the number. They're integer pairs whose product is the number, factors of a number. So 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 7 doesn't work, but 8 and 9 does. So 72's factors then, 72's factors are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Now, I should preface the notes that we're going to get to today by saying if you can't do that, you're not going to be able to do what we're doing. Part of factoring binomials and trinomials is to find factors of a number. So if you don't have that skill, if you're lacking that skill, you're going to be lost when we do this. So hopefully that's a skill that you're comfortable with, finding factors of a number. It would be nice if we had a way to do that with technology. Now, I have an application for my TI-84, but I don't have my TI-84 installed on this computer, so I can't show that to you right now. I'm sorry. But are we okay with finding factors of numbers? Okay. All right. So factoring is dividing. That's what it is. So consider the number, consider 86. Consider the number 86. If we wanted to rewrite 86, we could rewrite it. We could say that 86 equals 2 times 43. That's kind of what we're going to be doing when we factor something. Okay? We could say that because factoring is dividing. 86 has factors of 2 and 43, and their product is 86. So that's all we're doing when we're factoring. Okay? Now, we could also say that 86 is something else. Maybe it's negative 2 times negative 43. How's everybody doing so far today, okay? All right. So mainly, we'll be taking a trinomial. Now, if you don't know what a trinomial is, well, it's kind of messed up. The book puts the cart before the horse. Trinomials are polynomials. We don't study polynomials until the next chapter. But a trinomial is just a polynomial with 3 terms. And in fact, usually we're going to be taking quadratic trinomials. Okay, so we're going to be taking a trinomial, quadratic trinomial, and factoring it into 2 binomials. And those binomials are going to be linear, and that's the main thing that this section's all about, is taking a quadratic trinomial and factoring it, or dividing it, or breaking it down into 2 linear binomials. So I'll just run through a quick example of what that's going to look like so you have a clue as to what I'm talking about. Quadratic trinomial might be x squared minus 17x plus 72. Something like that. Now let's think back a second ago to 86. We said that 86 is really 2 times 43. So what we're going to do with this trinomial is we're going to kind of break it down into 2 things that could multiply out to equal it. Hey, wait a minute, those parentheses, that looks like we're going to be foiling. Well, yeah, you kind of are. To check your work, you can FOIL to see if what you've done gets you back to where you started from. And so some people call factoring unfoiling, and I can see why they do. It makes sense. So, so I know to come up with, well, let me get my highlighter out here. To come up with x squared, I know I would have to multiply x by x. And to come up with 72, we already found its factors a few minutes ago. But I'm looking for 72's factors. 72's factors that are going to, oh, wait a minute. When you FOILed, I don't know if you remember this. I hope you do. I'm trying to get my magic marker going here. I don't know where it's at. I'm having one of those days. Just one of them days. Here it is. Here's my magic marker. So when we FOIL, this inner product and this outer product, they either add or subtract to make that, to make this negative 17x here. So I got to figure out what I should go with. I wonder what factors of 72. I wonder what factors of 72, wherever they went, where did 72's factors go? Which ones add up to 17 or subtract to be 17? 8 and 9, good. So I'm going to go back here and I'm going to use a 9 and an 8. And if I look at this 72, I see, okay, it's positive 72, which means I have to have a negative times a negative or a positive times a positive. But then if I back that thing up and I look over here, I see that negative, and I say, you know, I'll bet, I'm not allowed to bet in school, but I would bet that this is going to be a minus and this is going to be a minus. So you don't have to FOIL it out, but you should to check it. If you FOIL it out, you get x squared minus 8x minus 9x plus 72, which does give you x squared minus 17x plus 72. So you don't have to FOIL it out, but you should if you want to check it. And that's the thing I love about factoring. If you're good at FOILing, you can check your work and know beyond the shadow of a doubt that you did it right. We okay so far? All right. So I think right now at this juncture, what we're going to do then is go back and have a look at some of those types. Some of those types. Okay. So the book talks about this stuff with ax squared plus bx plus c, and they basically kind of said the same thing that we're doing, and they're talking about undistributing, and you can read that over on your own time. Let's look at example number 1 and see if we can't figure it out. Example number 1. Some of you in the way back can't see this, so here we go. X squared plus 9x plus 20. That's a 9 in the middle. It kind of looks like an A, but that's really a 9. Now, if I had to guess, I would say that there's probably 5 of you right now that could factor this in 8 seconds. You already know what it is. I'm hearing somebody say, oh, I'm done, I got it. So, in case you're not sure what you do, the first thing is look at this number. Factoring requires finding factors of a number. So we're going to look at 20, and we want 20's factors. 1 and 20, 2 and 10, 4 and 5, and we want 20's factors that are going to add up or subtract to equal the coefficient of the middle term. So I hope it's pretty clear what we're going to go with here. What are we going with? The 5 and the 4? Does it matter what order we put those in if we go with the 5 first and then the 4 first? It really doesn't because of the commutative or commutative property of multiplication. So we got an x and a 4 and a 5. And I'm not big on all these rules about the signs, but if everything's positive, then everything's positive. So what I mean by that is since this is a positive and this is a positive, we're going to go plus and plus, and that's it. That's it. How's everybody doing? Now, I did say that I would show you the difference between the TI Inspire and the TI Inspire Cast, so here it is. TI Inspire, try as you may to factor for me. TI Inspire, not the Cast, but the regular Inspire. Try your hand at factoring x squared plus, what was it, plus 9x? Plus 20, thank you. Try to factor that for the variable x for me. Who thinks it's going to do it? Anybody think it's going to work? Enter. Variable not defined. Variable not defined. You paid $149 for a calculator that won't factor a quadratic trinomial for you. But you're allowed to use it on the ACT. But you're allowed to use it on the SAT. But you're allowed to use it on the PARCC test, maybe. Well, let's go to the Inspired CAS. A lot of people have a misconception of what the CAS stands for. What do you reckon it stands for? What do you think? Cowboy, alien, ship, shootout. What else? Complicated, I don't want to say the A word, but complicated A word stuff. Yeah, that's kind of what it stands for, because it'll do that. What the CAS stands for is computer, what class are we in? Oh, algebra. It's a computer algebra system. It has an algebra system in it. It has a computerized algebra system that can do things that your math teachers don't want it to do for you, such as factor this for the variable x. You're not allowed to use the Inspired CAS on tests because it does all the algebra stuff that you're supposed to be able to do by hand. So, having said that, you could probably expect that the next quiz over factoring will be a pencil, paper, no calculators, no computers allowed quiz. And you would be right in assuming that. So, let's try this next one. In all honesty, if you know factors, you should be able to come up with these a lot quicker than the computer can. Then you could type it into the computer. Let's look at number B here. Number B here, we've got x squared plus 14x minus 72. So again, I'm trying to find 72's factors that are going to add up or subtract to be 14. So I don't think 1 and 72 is going to work, because if we added them, we'd get 73. If we subtracted them, we'd get 71, and that's not going to work. So that's out. Would 2 and 36 get her done? Yes, I did just go there. Yes, I did just say that phrase. Would 3 and 24 work? No. Dang it. What about 4 and 18? Oh, yeah, 4 and 18. So an x and a 4 and an 18. Now here's where people kind of hit the first wall. There are several walls that you're going to hit over the next 22 minutes or so. What about the signs? I could just throw them in wherever. It's all good. I could just throw them in wherever. Let me make this a plus and let me make this a minus. So remember, you can FOIL to check yourself. If I FOIL, I get x squared plus 4x minus 18x minus 72. So I get x squared. Yeah! I get minus 72. Yeah! And what do I get in the middle? A minus 14x. So did I do it right? It's just one little sign error. It's no big deal. It is a big deal. Yeah, sign errors are huge deals. So I guess that's not going to work. So I guess I got to start all over again. Why do people do that? They erase everything that they had. I see people do that all the time. Sometimes you did some pretty good stuff. What I would recommend when you're doing this printed homework tonight is don't use a pen, don't use a Sharpie, don't use a crayon. Why do people say that word that way? Crayon, it's crayon. Anyway, so we're going to go with an X, What do we say? It was 4 and 18? But which one gets the positive sign? The bigger one. It's positive in the middle. The bigger one gets a positive sign. I'm not going to write that down. You might want to make a note of it. But and there's so many contingencies that's why I hate those little rules. If this is a negative on this last term, if that's a negative on the last term, and then this middle term is positive, then the bigger of the two factors, when our A is 1, and there's so many contingencies, and that's why I don't want to write them down, because when A is not 1, it changes drastically. It totally screws up everything. So anyway, in this scenario, when A is 1, when the constant term is negative, and when the middle term is positive, the bigger factor gets the positive sign. So a plus here and a minus there, and that's going to get it done. Everybody cool with that? Now you might say, well, what about technology? Can I use technology? Well, sure. Let's go and get some technology offline. If we're getting technology offline, are we actually getting it offline, or are we getting it on the line? I don't understand that. Let's go to Mathway. Mathway.com. Mathway is so intuitive that you don't even have to tell it what to do. You don't even have to say factor this for me. It'll assume that that's what you want to do. So what do we have? X squared plus 14x minus 72. And check it out. It says, would you like me to factor that for you? It's going to say that in a minute, I think. Oh, no, maybe it doesn't say that for me. We don't need an equal sign. X squared plus 14x minus 72. Come on, wake up, little Susie. I think the interweb is messed up. Maybe we'll try this other one. I shouldn't show you this one. This is a computational knowledge engine. There's other ones out there, I'm sure. But so let's see. X squared plus 14x minus 72. Bam. Press enter. And I think our internet connection is slow. Oh, what's it? Oh my gosh, it's graphing the related function. It's breaking it down into its factorization. It put it in vertex form for me. Oh my gosh. Whoa, look at that. That's way better than Wolfram Out, or way better than Mathway. Go back. It says those are the roots, and we're going to talk about that pretty soon. Wow. So I think I know what I might be using instead of Mathway. It's weird, though, because it's kind of like Spanish class. It's like Spanish 3. You need to know the language to understand what the heck's going on. And if you do, you'll have a great time. If not, well, then you'll take French 1. That was so low. I shouldn't have said that. But it's true. Okay. Number C. Number C. We have a problem. I said you're going to hit walls along the way. This is our first problem. Math teachers, math people, mathematicians, I'm going to use a really strong 4-letter H word here. Mathematicians hate leading negatives. Can't stand them. They're horrible. They're awful. So what I'm going to say is I'm going to say, on this one, let's divide out the -1. But keep it. But keep it. Sometimes we divide something out and we can discard it, but in this context, and we're going to see in the next section, we're going to divide out a -1 and we can discard it, but in this section, we're going to keep it. So we're going to divide everything by -1. So here's what we have, -x squared plus 13x minus 12. Before we start, we're going to divide out a -1. So we're going to divide a -1 out of this, a -1 out of this, a -1 out of this. So we write -1 times the group of. And when you do this, everything's SIGN sign changes from whatever it is to the opposite of whatever it is. So my first term is going to be what? X squared, and then my next term is going to be minus 13x, and then my next term is going to be plus 12. Everybody cool so far? So I did say to keep it. What I mean by keep it is let's just rewrite it out front, okay? And now, and here's where people hate this. I know hate's a strong word, but people hate doing this. But let's just forget it's not even there while we factor, okay? Let's just forget forget it's there. Forget about it. It's legal. We can cover it up for a minute, but we don't want to forget about it. So, this is going to make it easier to factor, isn't it? X, I said X and X. Come on, write. Why are you not writing, you silly goose? X and X. X and X. So what are we going to have? A 12 and a 12 and a 1, a 1 and a 12, minus and a minus. Then that'll get it done, right? Now here's the dealio. Here's the price of rice. When we have our answer is not just that stuff. Our answer is not just that stuff. If you don't believe me, let's go on the line. Let's go to the TI Inspire CAS and see what it has to say. Because remember, it can factor all this stuff for us. So TI Inspire CAS, factor -x squared, was it plus 13x and then minus 12? Thank you. Good looking out. It was minus 13x and then plus 12? Hold on a minute. It was plus 13x and then minus 12, wasn't it? Plus 13x and then minus 12. Plus 13x and then minus 12, yeah. Okay, bam. See how it puts the negative sign out front? We need to have that negative sign out front. If you don't, it's wrong. So rather than writing a -1, let me just put a negative sign out front. And so that's my answer. Everybody okay with that one? If the first term is negative, divide out a negative, and a negative will have to stay there. From a graphing perspective, if we were graphing a function, who can tell me why we need to hang on to that -1 out front, or that negative out front? Because it's going to tell the graph that it opens downward. Good, you got it. Everybody cool so far? Well, we're just scratching the surface, and we got 17 minutes to go. Okay, real quick then. X squared plus 14x plus 40. Everything's positive, so everything's positive. What are we going to go with? 410. Good. The next one, x squared minus 11x plus 30. The last term is positive, which means the two signs have to be the same. So 30's factors that add up, a 5 and a 6. Okay, a 5 and a 6, and both of them are negative. There we go. Everybody cool with that one? All right, these should be easy pickings. In this next one, we're going to divide out a negative. It's going to give us negative x squared minus 14x minus 32. So the negative goes along for the ride. An x and an x. 32's factors. One of them is going to have a positive sign. One of them is going to have a negative sign that add up to, or subtract, to be 14. Think, McFly. 9 and 4? No, that's going to give us 13. Or 5. 18 and 32 is not divisible by 18. Or 8 and 4. No, 8 and 4 is not going to get it done. Oh, 2 and 16. 2 and 16. 2, 16. Which one gets the negative sign? Look at the middle term. The middle term's a negative 14, right? So which one gets the negative sign? The 16. The bigger one gets a negative sign here. So a negative there and a plus there. Okay, that's going to be the hardest part that you're going to struggle with is which one gets which sign. Okay. Real quick, I want to show you another classic example that comes up. These look pretty similar, don't they? Let's look at the bottom one for a minute. The bottom one here, what are we going to go with? What factors? Now the factors are going to have the same sign because it's 6 and it's a plus 6. The factors are going to have the same sign, so it's going to be a positive and a positive, but since the middle term is negative, it's got to be a minus and a minus. So what are the factors going to be? Minus 2, minus 3, right? Okay, now let's look at the top one. When we look at this top one, we say, hey, it's the same thing. Is it? Because of the negative on the end, the signs are going to be different. So we're going to go with an x and an x. What do we got to go with on this one? Can we do a 2 and a 3? We got to go with the 1 and a 6 here. Which one gets the negative sign? 6 gets the negative sign on this one. Okay, be real careful on those because those ones they could factor a couple different ways depending on the SIG and S on the signs. All right. Now we talked about special cases before, so the special cases when we get to them are going to go real fast. But here's our next wall that we're going to hit. A GCF of 3x squared and 27x. Remember I said at the beginning that factoring is dividing. And you have to be able to find factors. And sometimes you have to be able to break something down into all its factors. 3x squared, if we break it down into its factors, it's just 3 times x times x. Now 27 can be broken down a little bit further than that. 27 can be factored down into 3 times 3 times 3 times x. So the question is, what's their greatest common factor. Another way to phrase that is, okay, look at what they all have in them, and let's see as much as we can get that's in both of them. What do we got? 3x, good, yeah. This one's got a 3 in it, but you say, well, wait a minute, this one has 3 3s. Yeah, it does, but the other one doesn't. This one over here has 3 3s, but this one only has 1 3. So the greatest that we can do with respect to the 3s is just 3. And then you say, well, this one's got x squared in it. Well, yeah, it does, and that's nice, but this one only has x in it. So the greatest amount that they have in common then is what he said, it's 3x, okay? So the GCF then is 3x. Does that make a little bit of sense? So let's divide out the GCF then. So if we have 3x squared plus 27x, if we have 3x squared plus 27x, what we can do to factor it is this. We divide by 3x, and it leaves 3x times some stuff. And this is where I kind of like breaking things down into the factors, and some people really don't like the way I show this, but for me it works. For me it works. If I go back to the factors that I had, once I divide out that 3x, this 3 is going to go away, this x is going to go away, this 3 is going to go away, this x is going to go away. So what's left? What's left is an x and a 9, and since it's a polynomial, I do need those operators in between. So it's x plus or minus 9, plus 9. Does that make a little bit of sense? Okay. So some of the ones that we're going to look at here are going to be just like that. So let's get right to it. So on this first example, I'm going to change the ends to x's. I've got 6x squared plus 9x. What's my GCF that I could factor out? What's my greatest common factor? 6 and 9 are both divisible by 3, and n squared or x squared and x are both divisible by x. So I'm going to divide out a 3x, which leaves behind 2x plus 3. Okay? 3x, which leaves behind a 2x plus 3. Now, I know the phone ringing's bothering some people. I'm just going to let it ring. They'll come up and get me if it's real important. This next one, I got 4 and a 20 and a 56. What can I divide out? A 4 and a 20 and a 56. If you know your factors, you'll be able to figure it out. 4. So I get 4 times x squared plus 5x minus, what's 56 divided by 4? What's 56 divided by 4? 56 divided by 2 is 28, so let's divide that by 2. Is it 14? I think it's 14. Okay. Now, here comes Santa Claus, right down Santa Claus Lane. Notice that 4 is sitting out front. We don't get rid of it. We don't discard it. So here's the 4. Here's my x and my x. Can we factor this again? Does 14 have factors that add up or subtract to be 5? 7 and 2. 2 and 7. Here we go. 2. Here's 7. Which one gets the positive sign? The 7 gets the positive sign because the 14 is negative, which tells us the signs are different. The 5, it's a positive in the middle, so the bigger one gets the positive sign, and there we go. That's that one. Okay. If you don't believe me, well, you could look it up on Wolfram Alpha or maybe a TI inspired cast if you're lucky enough to get your hands on one of those. Okay. So on these ones at the bottom, we've got 7x squared minus 21. What can we factor out of that? What can we factor out of that? A 7, good. So if we factor out a 7, that leaves behind x squared minus 3. Okay. On the next one with the 9s in it, 9x squared plus 9x minus 18, we could factor what out of that? A 9 out of that. And if we did, it'd leave x squared plus x minus 2. Hey, can we factor that again? Does 2 have factors that add up or subtract to be 1? I think so. X, 1, 2, which one gets the positive? The 2 gets the plus sign there. There we go. Okay. That last one, I'll let you try that on your own if you want to. So here we are. Oh, for sake of time, I'm going to show you how I do this. You're probably going to ask, how in the heck did you do that, Mr. Minnick? Well, we'll talk about that tomorrow. I'm just going to walk through step by step. I'm not going to explain much about how I do this, but I am going to work this one. So on this one, like I said on the YouTube video, this is going to be on YouTube. You might want to watch this one over a couple times to see what happens here. What I'm going to do is I'm going to look at this first term and this last term, just the coefficients. I'm going to multiply 2 times 12 and I get 24. And I'm going to break 24 down into its factors, which are 3 and 8 are the ones I want. This is kind of weird the way I do this. I'm going to rewrite this as 2x squared plus 12. But instead of writing 11x, I'm going to write plus 3x plus 8x. And there's a technique called factoring by grouping that we haven't seen yet. And again, we'll go over this more on tomorrow. And I did just say more on. I'm looking at these first two terms, and I'm going to factor an x out, which leaves a 2x plus 3. I'm looking at these next two terms, and I'm going to factor out a 4 out of that, which leaves behind a 2x plus 3. And if I understand the way the distributive property works, and I understand the way binomials work, what I realize then is my answer is going to be 2x plus 3, and then the other part of it's going to be x plus 4. Okay? Now that's a technique that's a little bit complicated to follow. You could guess and check on these, but you're going to have to FOIL, and you're going to have to be really great at foiling. And you're going to have to remember that the outer product and the first product and the inner product is different than normal. The last product will be the same, but the outer product, the inner product, and the first product is going to be a little bit different than usual. Okay. So I'll show one more of those. Like I said in the YouTube video, you might want to watch this back. So here we've got 4x squared minus 4x minus 3. So I'm going to take 4 times 12, or 4 times 3, I mean, I'm getting ahead of myself, which is 12. And I'm going to go with a 2 and a 6, so I'm going to write this as 4x squared minus 3. I'm rewriting this minus 4x as plus 2x minus 6x. And I look at the first two terms and I factor out the greatest common factor. And I look at the next two terms and I factor out the greatest common factor, which is a negative 3, and that leaves behind a 2x plus 1. And so when I factor this, my answer then is going to be 2x minus 3 and 2x plus 1. Okay. So ones like that, if you can't get them tonight, don't feel bad. If you do, awesome. But the technique that I'm using here is called factoring by grouping, and we'll talk more about that tomorrow. Okay. So in the time that's left, we're going to go over the specials. These should go really quick. We already talked about this a couple of weeks ago. Take a minute, put this in your notebook. A squared plus 2ab plus b squared equals a plus b, the quantity squared. A squared minus 2ab plus b squared equals a minus b, the quantity squared. These are called perfect square trinomials, and they factor into a binomial squared. It's kind of weird. Perfect square trinomial, binomial squared. And if you follow the pattern, these are real easy to figure out. If you follow the pattern, they're real simple to figure out. All you do is take the square root of the first term and take the square root of the last term, and then look at the sign of the thing in the middle. That's really all you do. Square root of a squared is a, the square root of b squared is b. Whatever the middle sign is, that's what the sign is. So this first one, what's the square root of 4x squared going to be? What's the square root of 4x squared? Square root of 4 is 2. Square root of x squared is x, so that's going to be 2x. What's the square root of 36? 6. The sign in the middle is a minus, so we're going to go with the minus, and we're going to go with the square here, and that's it. That's it. Can anyone see something that we probably could have and should have done to this first, since we have a 4 and a 24? And oh yeah, we could have divided out a 4. Had we divided out a 4, it would have been 4 times x squared minus 6x plus 9. The 4 goes for a ride, and here we get an x and a 3 and a minus and a squared. We would have got the same thing. And I know what you're saying. You're saying, Mr. Minnick, there's no way. There's no way that 2x minus 6, the quantity squared, ends up back to where you are. I don't believe it. I don't think it's right. Well, if we FOIL it, we get 4x squared minus 12x plus 36. And this does give us minus 24x. So you might say to yourself, okay, well, which one's better? Which one's right? They're both right, but one is better. Who could tell me which one's better? Which one's better? The one on the left or the one on the right? The one on the right's better. Moral of the story, if you can factor out a GCF first, do it. If you can factor out a GCF first, do it. So we got one more special, and I've got to get the homework passed out before you pass out. So the other special, here it comes. It's a squared minus b squared. It's the group of a plus b and the group of a minus b. And again, we've seen this a while ago. We're just taking square roots. And we're going to have two binomials. One's a plus, one's a minus. A plus, a minus. What's the square root of 25x squared? Square root of 25x squared is going to be 5x. And the square root of 49, I hope everybody remembers that one. It's a 7. We'll have 5x and a 7 and a 5x and a 7, and that's it. I'm out. That was factoring. I know some of the stuff went pretty fast. At the beginning, it kind of went slow. This will be on the line. It will be on YouTube. I wish everybody the best of luck on the homework. See you next time.